Hello, good afternoon, everyone. Hope you had a good weekend. We will try to finish lecture one today, depending on um, whether there are questions or not, we might or might not be able to finish. Whatever we don't finish, we will definitely complete it on Wednesday's class. So let's get started. Last class, I believe we left off with talking about the concept of um, inductive reasoning, right? So let's recap what that means. Okay? In inductive reasoning, um, what happens is you make a bunch of observations. Okay? And these observations can be qualitative, quantitative, doesn't really matter. But you are making a bunch of observations. These individual observations about a particular event that you're looking at, or about a particular group of organisms you're looking at, right? Doesn't really matter. You make a bunch of observations, and from these um, specific observations, you try to come up with some kind of generalization. Okay? So that is what we call inductive reasoning. So we did an example last class. I was saying the tree is made up of cells, birds is made up of cells, fish is made up of cells, mushrooms made up of cells, and then the generalization that we come up with is all living things are made up of cells. Okay? So this generalization might or might not be correct. That's not the point. It's just something that you come up with based on everything that you have observed. To see whether it's actually correct or not, we actually need to do an experiment to figure it out in many cases. So then, from this generalization, we can actually apply it to various examples. Right? We can apply it to a specific examples and make a prediction, basically. And that is what we call deductive reasoning. Okay, so let's say the generalization is that all living things are made up of cells, and now I discover a new living thing. I discover a new organisms. Nobody have ever seen it before. And since it is living, then we can conclude it is also made up of cells. If you remember the story about my daughter, after she figured out, okay, everything on this aisle is $2, and then that's a generalization. And since I got the eraser off this aisle, it's probably $2 as well, right? So applying the conclusion that you've created to a specific example, right? That is deductive reasoning. So the um, flow of information for inductive reasoning goes from specific to general, whereas for deductive reasoning, it goes from general to specific. Um, does that make sense? Anybody have any questions?
Yes, it makes sense.
Okay, good. Thank you. All right. Um, we are gonna do a lot of pollings in this course along the way to see whether you understand some of the concepts I'm trying to teach you. So please take a moment and um, try this out. Okay, if you cannot see the poll for whatever reason, feel free to message me your answer. Okay, just gonna leave this up for about a minute. Okay. The polls are anonymous, so feel free to choose something that you think is correct. It's a great way to check whether you understand what's going on or not. Okay, anyone else before I close the poll? All right, so here are the results. Let's take a closer look at this question. I'm gonna copy it over. Give me a moment. All right, so the question asks for deductive reasoning. Okay, deductive reasoning. So based on what I explained to you, deductive reasoning goes from, you can see over here, general to specific. You are applying a general concept to a specific example. So general to specific, that's what you got to write down. All viruses require a host to replicate. So that sounds like a general statement. Okay. All living things are made up of cells. That's a general statement, right? So similarly, that's a general statement. So that's possibly the answer we're looking for. But let's keep on reading. COVID-19, HPV, Ebola, influenza of viruses, they require a host to replicate. Therefore, all viruses require a host to replicate. This is going from specific examples, right? Like this is a specific example, another specific example, right? So on and so forth. So that this is going from specific to general, which is actually inductive reasoning. So that's not the answer. Okay? We're looking for deductive reasoning. Next one, all viruses require a host to replicate. Again, it sounds like a general statement. It's very similar to A, so that could be our answer. Let's mark it down first. Next one, COVID-19 is a virus and it requires a host to replicate. Ebola is a virus, therefore it also requires a host to replicate. These are just two specific examples. There is no generalization going on, which is not what we are looking for in the question. So is it A or is it C? Well, let's take a closer look here. And I'm going to try to help you understand with a little bit of highlighting, okay? So all viruses require a host to replicate. That's the generalization. And then you apply it to a specific case. You apply it to COVID-19. So COVID-19 is a virus. It must require a host to replicate. Right? So the general statement goes like this. If yellow, then blue. And then our statement, it's because it's yellow, therefore it's blue. Let's take a look at the other example. All viruses require hosts to replicate. So same thing. If yellow, then blue. And then it says COVID-19 requires a host to replicate. Therefore, it is a virus. So in C, you can see the logic has been flipped. Right? The generalization is that if yellow, then blue. But then the statement, it actually says, oh, if it's blue, then it's yellow. Right? You see, it's opposite to what the generalization is talking about. So therefore, this is actually not correct, and that's the right answer. Now, if you have trouble understanding what I mean by the flow of logic, let me give you an example that's easier to comprehend, okay? So watch. Let's say all birds have wings, which is true. Okay, all birds have wings. All right, so this is yellow followed by blue. Okay, if yellow, then blue. If it's bird, then it has wings. All right. So now I'm gonna say this. Bees have wings. Therefore, if I follow this logic, what am I gonna say next? Therefore, bees are birds, right? And you can quickly understand why this is wrong. Right? You see, if you flip the order of the logic, if you say, okay, blue first, then it must be yellow, right? Then it's not going to work out, right? Obviously, you know bees are not birds, right? Okay, so in order for the argument, for the reasoning and the logic to make sense, when you apply it to a situation, you have to apply it in the same order that it appears. Are we together on this? Okay, like not every single question will be this difficult on the quiz, don't worry, but there will be some that requires a little bit of thinking. Right? So, go through that again later if you need to. All right, let's go back to the PowerPoint slides. So, the stuff we are talking about, right? It's part of discovery science. There are two main approaches in terms of how people do science, right? There's discovery science where you're making observations without changing anything, right? Qualitative or quantitative observations. And from those observations, you can come up with some generalization, which then you can apply to other situations, okay? And then the second part of this scientific process is called scientific method or hypothesis-driven science, which is what we're going to be spending most of our time talking about today. So here is an outline of the scientific method. It has various steps in it. And like I said, understanding the scientific method is crucial in helping you do well in your first lab. Right? So make sure you pay attention and ask questions if you need clarification. So there are observations, asking questions, making a hypothesis, predicting the results, setting up an experiment and actually performing it. And then based on the data you've gathered from the experiment, coming up with a conclusion. That's basically the scientific method. I'm going to go through each step in detail. This is just an overview. Let's start with something that's, most people can relate to. Let's say you want to watch some TV, get the remote, you press on it, and nothing happens. So that's a problem, right? What's the observation? The observation is that the remote does not work. And the question that we ask ourselves is, what is wrong? Why isn't it turning on? So then we make a hypothesis, right? I'll tell you more about a hypothesis later, but it's basically like people call it like an educated guess. Right? So based on your previous experience, based on your life experience, you have some idea why this is the case. Like why is the remote not working? Maybe the batteries are dead. That's your guess, okay? So then you make a prediction. You're like, oh, if I'm right, replacing the battery will fix the problem. Right? And then if I'm wrong, then replacing the battery will not do anything. So then you go ahead and you experiment with your prediction, experiment with your hypothesis. You replace the batteries, and if it works, that means you fix the problem. Your prediction was correct, and you solve the problem. Otherwise, if the batteries are new and the remote still does not work, then you need to revise your hypothesis. You need to come up with a different possibility. Okay, maybe it's not the batteries. Maybe it's the TV is unplugged. Okay, and then you go check and see. All right, so eventually we go through cycles of this hypothesis experimentation until we are able to find the solution and solve the problem. Okay, so that's basically hypothesis-driven science. And I don't want you to think of the discovery science and this hypothesis-driven science as two separate things. They often happen parallel to each other. And they kind of complement each other. As you can see here, deduction usually takes the form of predictions about what experimental results or observations are expected if the hypothesis is correct. Okay, so you are applying the generalization that you're making, right? Remember, we don't know if the generalization is true or not, right? It's just based on our observation, based on our previous experience in life, we think this is true. And then whether it's actually correct or not, you have to do an experiment to figure that out, right? So that part is where the deduction is happening. So we're gonna go through a few scenarios, and hopefully it's gonna make sense to you at the end. So we start by making observations, right? And every day we go through our days and we see many things happening, right? Sometimes we question why certain things are the way they are, but we rarely go through and try to find out the answers. We're too busy for that, right? Most of the time, okay? But let's say you notice in your house, some plants grow taller than the others, right? So one plant is shorter, the other plant is taller, and you might wonder why, right? What is causing the difference? So that's the observation part, and then asking the questions. And then you're gonna try to answer your question, right? The hypothesis is the best way to talk about to think of a hypothesis is that it is a tentative answer to your question. Okay, again, people call it an educated guess. Educated guess. My best guess. Right? In order for a hypothesis to be valid, it must satisfy two criteria. Number one, it must be testable. Testable means you must be able to do an experiment to check it. Okay? If you can't do an experiment to check it, then it's not a valid hypothesis. I'm not saying it's not a good guess. It might be a good guess, but scientifically speaking, you can't test it, then it's not a valid hypothesis. Number two, it must be falsifiable. Falsifiable means it's it can be potentially wrong. You cannot come up with a hypothesis that's always true. If you know it to be true, then what's the point of asking the question in the first place? You already know the answer, right? Often we want to do experiments to find out things that we don't know about, right? So the hypothesis that you create might potentially be wrong. So keeping that in mind, things like opinions, cultural or religious beliefs, superstitions, myth, value, moral judgment, supernatural stuff, those are not testable, right? They cannot be part of your hypothesis. Any questions? Now, for those of you who are just joining us this week, I just want to remind you, if you log on to the course homepage, you will see this big green tab. That is where you can, excuse me, access the lecture recordings. Just click on it, and it will take you to this online document, and that's the recording for last week, right? And then after today's class, I will post another recording, right? So you can always go back and check more. There are also class notes. This is the notes we wrote down last class. I'll write more today, and then I'll post it. So this folder is gonna keep on growing over the course of the semester. So we're working on the scientific method right here. That's where you can get the notes and the study guide. All right.
After each class, you will share notes, right? Like after each class.
That's right. So this is if you click on it, you will see that this is the stuff we wrote last class. It's not a lot, okay? But as we go on to harder topics, the notes will get more and more complicated, and I will always post it right here in this folder with the green sticky tag. All right.
So it's enough, good enough for reviewing things, right? Your notes.
Yeah, absolutely. So for studying, just go through the PowerPoints, go through the class notes along with the study guide. That should be more than enough. And of course, there is the self quiz. If you go to study resources, there is a self quiz right here. I don't think any of you have done it yet. They are formative. They don't count as marks, but it gives you a good idea of what questions would appear on the test. Definitely do them, especially the first one here. It will force you to install the Lockdown browser. That's something that you need to have in order to do assessment in our program. Okay, not just for biology, but for your chemistry and math as well. So try that today if you can, please. Okay, so that's what a hypothesis is.
Sorry, this quiz only for practice.
That's right. The self quiz are only for practice. You can do them as many times as you like. It's not gonna be part of your grades, okay?
Teacher, I have a question. So,
Mhm.
I'm kind of confused because it's first time I am studying science in English. So, what can I do after each class? Which steps I need to take for better understanding? For example, for going through your notes or PowerPoint.
Yeah, definitely go through the PowerPoint and but more importantly, you should do the study guides, right? Here is the example of the study guide, right? Just go through the questions. For example, we talk about 7 characteristics of living things, right? So you should use this, fill it in, write it down, write it down. Even though you guys are doing this course online, definitely write the notes down multiple times. It's going to help you consolidate your understanding, okay? So fill it in, and then the answers are also available. Look here, right? That's the answers. And then you can check the answers yourself after you do it, right? Okay.
Mm-hmm.
Now there's also another options for those of you who speak another language. I tried this out. It's actually pretty good. When you go on the Luminate, next to the file there is this like triangle button, and you can press on it, and it says there's translated version. So if you click on that, you can choose the language that you prefer. I mean, I only speak English and Cantonese, okay? I download the Cantonese version, and it's a reasonable good translation. All right. So maybe it's going to be helpful for some of you, maybe not. I don't know. But there is the option for you if you need them. Okay?
Okay, thank you.
No problem. All right. So let's take a look at some invalid hypotheses. Hypotheses is the plural for hypothesis. Animal testing is bad. Now, that is not a good hypothesis because it is an opinion. We cannot test for an opinion, and therefore it's not a valid hypothesis. It's not testable. Right? Same thing. Rock music are better than classical music. These are not testable. Next one. The garden fairies made some plants taller than others. What is wrong with this one? Why is this a bad hypothesis? Feel free to type the answer in the chat box or unmute, whatever you're comfortable with. Why is this a bad hypothesis? Okay. Someone said it's a myth.
Not decide before.
Cannot decide before. Okay. Fiction. All right. Yeah, this is superstitious, right? But more importantly, this is not falsifiable. Okay, not falsifiable. Fiable. What does that mean? What does it mean? Well, you can sit in the garden for your whole life and not see a single garden fairy, but that doesn't mean they don't exist, right? Okay, maybe you just have bad luck, you didn't see it, right? So it doesn't matter how much time people spend observing the gardens. The counter argument is always, you're just not lucky enough to see one. Yeah, if we wait long enough, then you might be able to see the garden fairy, right? So there's no way to say that it is wrong. It's not falsifiable, therefore it's not a valid hypothesis. Make sense? Everything that occurs is as a result of divine intervention. Okay, so again, there's some religious belief here, some superstitions, perhaps, depends on how you look at it. And anytime we involve these things, then they are not testable and they're not falsifiable in some cases as well. So these are all bad hypotheses. I want to stress the fact that hypothesis is supposed to be a statement and answer to your questions. Do not ask more questions when you write your hypothesis. That's where people make mistakes when they do the lab. I ask you to write a hypothesis, and then they end up writing it in the form of a question. So be sure to understand that this is a statement to address your question. All right, so here are some good ones. Plants receiving more sunlight grows taller. Right? In our observation, we saw one plant grow taller than the other. Right? Why is that? Well, one possibility is because one is receiving more sunlight. And here's another hypothesis for a different scenario. Driving with the windows down will increase fuel consumption. right? Some people believe that, and others say, no, if you drive the window down, all this drag, all this resistance are coming in and actually will be worse. But if you close the window using your AC, it could actually end up using more fuel, right? So both sides of the argument. That's something that's easily testable and easily determined whether it's true or not. Taking melatonin will increase sleep duration. And melatonin, it's like well, it's a hormone that your body makes, okay? But then you can buy them from Walmart and other wellness store, and people take them. And some people swears by it. If you take it, I sleep better. Others say, nah, it's just all in your head. Is a what we call like a placebo effect. Again, that's something we can easily test, right? So that's why these are valid hypotheses. Okay, let's talk about designing an experiment. When we design an experiment to test our hypothesis, there are lots of things that could change in the experiment. Right? Anything that can change in an experiment is what we call a variable. A variable. When we set up an experiment, we try to keep all the conditions the same, and we try to standardize everything except for two things. And one of them is the dependent variable. The other is the independent variable. So I'm going to try to explain this to you. It's one of the things that people kind of have a hard time understanding. So I will try my best to help you understand it, and you will need to know the difference for the quiz as well as for the lab. All right, so let's talk about independent variable. Okay, please write this down. So in an experiment, the independent variable is the variable that is being changed by the person doing the experiment. And one way to remember it, this is that the independent variable is the one that you are in control of. Okay, in control of. You deliberately, you purposely change this variable. Okay? And then you want to see, hey, if I change this thing, what's going to happen? Okay? That's the independent variable. So, for example, if we want to do an experiment to check and see if the amount of sunlight is going to change the height of the plant, then the independent variable would be the amount of sunlight. Okay? You can have a plant with regular amount of sunlight. You can have a plant with, double the amount of sunlight, and so on and so forth, right? So that would be the independent variable. The variable that you deliberately change, the variable that you are in control of. The dependent variable, it is the variable that is being observed or measured in an experiment. Okay? So for example, it would be the height of the plant. The height of the plant. So by changing the amount of sunlight, will we see a difference in the height of the plane. So independent variable, you're changing it, and then you want to see if it has an effect on the dependent variable. Right? So let me write that down for you. In any experiment, the purpose is to investigate how the independent variable affects the dependent variable. It might or might not have an effect. Okay, not all changes is gonna result in a different outcome necessarily. Right? It depends what you're studying, and that's kind of like the purpose of running an experiment. You don't know what to expect. That's why you're doing an experiment to find out. So let's take a look at here. We had some examples earlier from the PowerPoint. Right. Plant receiving more sunlight grows taller. That's the hypothesis. And I already told you the independent variable would be the amount of sunlight, and then the dependent variable would be the height of the plant. How about the second one? If we want to do an experiment to test whether or not driving with the windows down will increase fuel consumption, what would be the independent variable in this case? What would be the independent variable in this case? What are you in control of? Okay, good. I see an answer in the chat box. Anyone else? Yes, Natalie, you wanna, or no? Okay, I saw it. Yep, so here we'll say the position of the window, right? Position of the windows. Open or close. Right? So be a little bit descriptive. Don't just say window, right? Make sure I understand what it is that you're referring to. Like, what about the window, right? Is it the type of the window, right? Or like, so this is like opening or closing the window. So that's something that you can control. And then the dependent variable, that's the one you are going to be measuring and observing. And that would be the fuel consumption. Fuel consumption. Okay, let's try one more. What is the independent variable for this last one? If I want to do an experiment to see whether or not consuming melatonin will make you sleep longer or shorter, what would be the thing that you can control?
Longer.
No, okay, so that's a prediction, right? But then like, what are you going to be able to control?
Taking melatonin.
That's right. So this would be taking melatonin or not, right? Taking melatonin or not. All right, so maybe you get large groups of people, right? 100 people in each group. This group takes melatonin, this group does not. And then the dependent variable, which is what you are trying to observe and assess, and that would be the sleep duration. Are we together? Let me know
Yes.
if you have any question. All right. Now, in the study guide, there are more questions you can try. Number 6, right? There are different scenarios. Here, I'll do one more with you, okay? But then you should do them on your own after class, and the answers are posted, right? I have to keep on reminding people. In each of the following experiment, find which one is independent, which is dependent. So students watched a cartoon either alone or with others, and then rate how funny they found the cartoon to be. So which one is independent? Which one can you control as the person who's running the experiment?
I'm watching the cartoon.
Okay, and what about watching the cartoon? Anyone want to add to that? That's
Alone or alone or with others.
Watching together or alone?
That's right.
That is, yeah.
That's right. Okay, so watching alone or with others. Okay, there will be short answer questions on the quiz that requires you type the answer. Please be like you don't write me an essay, okay? But don't answer in short 1 or 2 words either. Okay, like try to at least make a sentence so that I can understand. Okay. Dependent variable, it would be the how funny the students rate the cartoon. All right, that's it. That is it. Now, we have a lot of people here, which is great. I just want to take a moment and tell you a little bit about the test. Even though this is an online test, right? First of all, you still have to study for it, obviously. You can't just go and write a test cold turkey, right? Like you have to study in order to do well. Right? So that's number one. You would study as if you were doing this in person. Okay, so go through all the notes, go through all the study guide. Right, that's the first thing. Number two, you will be using the lockdown browser, which means you won't have access to files on your computer. Okay, and so if you want to quickly look up your notes or something, you can't do that on your computer. However, if you print it out, that's okay. Like for my course only, I'm not talking about your other course. Your other teachers might have other rules, but for my course for biology, it is okay to use your notes during the test, during the quiz. Okay, it's fine. Even though if I say no, some people are gonna use it. So I'm just gonna say it's okay to use your notes if you want. All right. When I created the questions for the quizzes and tests, I already expect you to have your notes. So the level of difficulty has been adjusted accordingly. But listen to me, right? If you have your whole binder of notes, I don't recommend that. If you are doing the test, the quiz, which is like 40 minutes long, you're not gonna have time to flip through your notes and try to find where things are. Right? You're just gonna waste your time and not be able to finish. All right. What I recommend instead is creating like a one-page summary or like two sides front and back with some of the things that you find more difficult to memorize, perhaps. Okay. And you write that note out. Don't even type it out. Write it out because it helps you remember what's on it. And then just have a reference sheet. So for things that you really need to do a quick look, quick look and double check, you have that option for you. Okay. Don't use the internet to find the answer on the test. First of all, you have the lockdown browser. You're not going to be able to access the internet. I know you guys have your phone and whatnot, but you just won't have time. Trust me, right? It's much better if you study yourself and then have some help sheet next to you. Any question regarding that?
Yes, I have a question.
Sure, please go ahead.
About our finals, and do we have midterm exams?
Okay, so everything about the evaluations was covered last class. So if you missed that, please watch the recordings. It will explain to you, how many tests, how many quizzes we have, and what they cover. Okay, but
Okay.
short answer to that is no, no final exam, but there is a final test.
Okay.
I saw
And
another
is
question
it done in
earlier.
person
No,
or
online. Everything is done
online?
online. Okay.
Okay,
Yeah, so
thank you.
please watch the recordings from last class.
Thank you.
Someone else? Gunaz, was it you? I think it was you, right? Who unmute? Or maybe it was someone else?
No, that's fine.
No, you good?
I
Okay.
understand. Yes.
All right. So hopefully that gives you a little bit of relief, knowing that you have that help sheet. The questions are reasonable though. Okay, like there's nothing crazy about the test. Okay, moving on. So here we just to refresh your memory, we had a hypothesis. Some plants are taller because they receive more sunlight. Okay, that is, we're trying to answer the questions why some plants grow taller than others, right? And then you can do an experiment. You're gonna have a plant here that receives 6 hours of sunlight, and then you're gonna have another plant that receives 12 hours of sunlight. Now, what's really important is that when you set up this experiment, okay, let me go back to the notes here to tell you more. We have two groups for our experiment. Okay, so here we have the group here, with the plant, and this is going to be receiving 6 hours of sunlight. Okay, so this one is what we call the control group. Control group. Control group is no modification. Okay, it's just the way it is. There's no added stuff to it. It's the normal conditions. So that's called a control group. The purpose of the control group is to provide a reference or a baseline to compare with. Okay. I need to have a reference. I can't just take one plant and then give it more light and then it grew 10 centimeter and then I cannot make any conclusion. Like, how do I know 10 centimeter is a lot or it's just the regular amount that it would have grown anyways, right? So I need to have something to compare with, which is what the control group is for. Okay, so that's a control group. And then here you would have another group. I'm just gonna copy the plan over. Okay, another group. And this one will receive more sunlight, 12 hours of sunlight. So this is called a treated group or the experimental group. Okay, so this one is going to receive modifications. One modification. You cannot modify more than one thing at a time. Okay. So between the two groups, everything should be standardized, except for the independent variable. Okay. Because we're trying to see whether or not the amount of sunlight will affect the growth, the height of the plant. Everything else needs to be the same. For example, here I'm going to give you a list, e.g. amount of water. Okay, you have to water both plants with the same amount. You can't change the sunlight and the amount of water. If you do that and one plant grows taller than the other, you don't know if it was the sunlight or if it was the water or the combination of both. Okay, you can only test one thing at a time. So help me out. What else? What else do we need to keep the same between the two groups here?
Enough sunlight?
Okay, so we are testing sunlight, so that's not something we will keep the same. Right? In fact,
Oh,
one plant will have less sunlight than the others. Yeah.
Soil?
Soil type, very good. Temperature, humidity, yep. Anything else? Environment, yeah. Okay, so all these things you need to keep the same, right? The type of plants, right? So that in the end, if we do see a difference in height, we know for certain it's because of the sunlight and not any of these things. Okay, it's not the water because they are the same. It's not the soil, temperature, humidity, nutrient, right? None of those things, right? Because they are all the same. The only thing that I change between this group and this group is the sunlight. So if they grow in different height, then it has to be the sunlight. Understand? So that's this list of things that we keep the same. They are called standardized variables. Different experiments require different standardization. We'll do more examples later on. Okay, so we're going to predict the result. If our hypothesis is correct, if sunlight actually makes plant grow differently, then you would expect the plant with more sunlight to be taller. Otherwise, if the hypothesis is incorrect, then the plant should be similar in height, or giving it more light actually makes it shorter. That's possible. Some plants don't like light that much. If you give them too much light, they start to stun the growth. Okay, so that's the prediction. And here are the results. Let's say after 7 days, the one receiving 6 hours of light only grew 1 centimeter, and then the other one grew by 6 centimeter. So based on this result, it's reasonable to conclude that the data is what we collected here, supports the hypothesis. Right? You see?
Professor,
Yeah.
length of amount of light here is only 6 and 12. Some crop may be sensitive on light. If is it good if we do 6 hours, that is constant, and then for example 8 hours, 10 hours, 12 hours, and then 14 hours. And
Absolutely. Yeah, that is a great point. And I was going to get to that. Just hold on a second. Thank you, though. Okay, so like, of course, this is an oversimplification, right? So just 6 hours and 12 hours, and then we see 1 centimeter and 6 centimeter. Just give me a moment. I'll circle back to that point. And you can say, the plant receiving more light will grow taller, and therefore it support our hypothesis. Okay. Now in real life, right, when we do actual experiments, especially with like medications and stuff like that, like if there's a new drug that we need to test, first of all, we are not gonna just have two sample size here. Okay, this is one plant versus another plant. That is not enough data. So we actually need to have a larger sample size, we call it. Can you imagine testing the effectiveness of a vaccine? Okay, so we're gonna have two people. You're not gonna get the vaccine, you're gonna get the vaccine, and then we're gonna see what happens. Okay, and then afterwards we see the person receiving the vaccine is healthier. And then we say, okay, the vaccine works. Let's give it to billions of people, right? That's not how science works, right? So like you need to have like a large sample size, and after the result, you often have to ask more questions. So for example, we see that here 12 hours is better than 6 hours. So you might wonder, what is the optimal amount of sunlight exposure that would result in the tallest plants? And that's what the students were suggesting, right, earlier. Why don't we include more testing intervals, right? This group gets 6 hours, this group gets like 8 hours, 10 hours, 12 hours, all the way up to 24 hours, right? Then we can see whether or not this trend continues, right? So that's what good science is, right? You do a little bit of testing at the beginning, but then it always leads to more questions, and then you're gonna repeat more experiments and find out more about the subject, right? So, for example, if they found out the vaccine actually works, then maybe they want to figure out the dosage, right? What's the optimal dose, right? What's the do we need a booster, so on and so forth. Does that answer your question?
Yes.
Very good. All right, let's do another poll question. This one is much easier than the previous one, but it's worth doing as well. Go for it. Okay, I'm gonna end it there. Show you the result. Which of the following steps in the scientific method involves producing a tentative answer? Okay, so if we go back a few slides earlier, you can see hypothesis is a tentative answer. That's what it is. Okay, tentative answer right there. Okay, so there you go. A lot of people also chose experiment. No, experiment is actually testing your hypothesis. Okay, let's try this one. Okay, I'm not gonna leave the poll out for too long. We gonna move along. Thank you for those who have participated. Most of you got it right. I literally just told you the answer actually right before the question. If you're testing your hypothesis or hypotheses, then you need to do an experiment, right? The answer is D. All right, moving along. Who came up with this whole notion of scientific methods, right? Like who decided that this is how we're supposed to do science with the hypothesis and the, a prediction and so on and so forth. Well, let's have a little bit of a history lesson on that. So prior to the mid to 19th century, the origin of microorganisms like, bacteria and things like that in decaying matter came into question. Okay? People didn't really know where life came from. Right? So there are many theories about the origin of life. Okay, many people have a religious belief, and other people have a more like a scientific belief. And then there are some people who believe in what's called spontaneous generation. Okay, spontaneous generation. If you don't know what that is, it's basically a theory that states that living things arise from non-living things. Okay? And this is based on observations people made. If you leave a piece of meat outside for a couple of days and then you come back to it, you're going to see flies and maybe maggots growing on the meat. Right? So people are like, hey, that's spontaneous generation. The meat is not alive, but then after a few days, you see these living things kind of spawning from it, seemingly, right? So they took that as evidence that support the idea of spontaneous generation. Okay, life on its own spontaneously would arise from non-living things. That's not the only observations that supported the idea of spontaneous generation. There are other events people in the past, and it still happens nowadays. They observe fish and other aquatic life forms raining from the sky. Yeah, if you do a Google search, you will see it. This is January 4th, 2022. Texas witnesses a rare weather phenomena as fish rain from the sky. Here's another one in 2017. Fish fall from sky with rain in northern Mexico. Okay, it happens in Malta. It happens in Australia. It's a thing that happens. Have you guys heard of this before? Fish, frogs raining from the sky.
No, literally. Always
No, yeah.
happen.
So what happens, right? Like this sounds like fake news, right? But it's not. It's real. Okay. So what happens is there are these water spouts, okay, which are kind of like tornadoes that sweep through like a body of water, okay, maybe a coastal area or like a large lake or something. And the force of the water spout scoop up these life forms, including the fish and whatnot, and then they send them flying inland and they appear to be raining from the sky. Okay, so that's what happens.
Yes, I saw that video clip
Oh yeah,
in
there's a
the
video. Yeah.
Instagram. Yes.
Okay, yeah. So like there are probably video footage of that. Someone told me it's like the movie Sharknado, where like the sharks are raining from the sky. Okay, sharks are too big to be scooped up, so that's not going to happen. But then fish, smaller ones. Okay, that happens. Okay, and people in the past they don't have understanding of weather patterns like we do now, and so when they observe something like that, they're like, oh, this is it. This is how life came to be. It just rained from the sky, spontaneous generation. All right, that's the key thing I want you to understand. And so, in the 1600s, there was this person named Francesco Redi, and he really wanted to test the hypothesis of spontaneous generation. To him, it doesn't really make sense that life would just be able to spawn spontaneously on its own. And he believed there is a flaw to this concept of spontaneous generation. And so he came up with a process of making observations, asking questions, which ultimately become the standard of how science is being done, right? The scientific method. So his observations is that flies and maggots can be seen around pieces of meat left out on the counter, okay, or like outside. And the question that everyone seems to be asking at the time is, where do the flies come from? Is the rotting meat transformed into flies? If it is, then spontaneous generation is correct. If it isn't, then spontaneous generation is not correct. So the hypothesis that Redi, that's Francesco Redi, we'll call him Redi, R-E-D-I, he had a hypothesis. Only flies can make flies. Rotting meat cannot be transformed into flies. Okay, so this is a testable hypothesis. You can do an experiment to test this. And you can be potentially wrong, falsifiable. That's what makes this a good hypothesis. Now we're gonna take a note and show you what he did for his experiment, and we're gonna talk about the implication of it. Okay, so this is Redi's experiment on spontaneous generation. Just in case you missed it, spontaneous generation is a concept that describe living things arising from non-living things, okay, like the flies and the maggots coming from the rotting meat. Okay, I hope you know that is not true, right? Flies and maggots do not come from the meat. You and I should know that, right? Based on our experience. But they didn't know that back then. They had to do an experiment to figure it out. So this is what he did. All right, he got 3 jars. It was jar number 1. Okay, and I'm gonna just copy and paste to make sure that the jars looks the same. So we got 3 jars. Okay. In the first jar, he put a piece of meat in there. Piece of meat. Okay. Another piece of meat here in the second jar, and then another piece of meat. So this is the control group. Control group. Remember, the purpose of having a control group is to have a reference to compare your results with. Right? The control group is to show you what it looks like when you do nothing to it. So you put a piece of meat into the jar and you leave it outside, and you're gonna see what happens. Right? So this is an open container. Open container. Over here, we have our treater group. Treater group number 1. Right? So he's gonna have a netting cover right there, one of those screeners that you have. Right? So covered with a net. And then he had treater group number 2. And this one, he's gonna seal the jar. They did not have saran wrap back then. I don't know what he used, probably like a cloth or something. Okay. Seal the thing. It's gonna be a sealed jar. All right? So help me out. In this experiment, what's the independent variable and what's the dependent variable? Just give yourself a moment to think about that. What's the independent variable? Let's do that first. What's the one thing that he's in control of?
Should we write down in the chat box or
Up
just?
to you. You can say it, yeah, since you're unmuted already. If you feel comfortable, yeah. Or you can
Yeah, I
type it.
feel comfortable. So
Go ahead.
independent variable is the coverage of the meat.
That's right. So the type of
Yeah,
covering, right? You can say.
yeah,
Very
type of
good.
cover. Yeah.
Yeah. Okay. Anyone else for dependent variable? What are we what was he trying to observe? What was he trying to measure? What's the dependent variable? That's right. Kensha said the basically I'm gonna paraphrase what you said. The presence of flies and maggots, right? Presence of flies and maggots. Oops. There we go. All right, so that's how he set it up, and let's do a few standardized variable as well. What are things that needs to be kept constant for the results to be meaningful? We have 3 jars here. What needs to be the same? Okay, we should use the same kind of containers, but then with different coverings though, right? Okay. What else needs to be the same?
The same meat.
Good. Okay,
Type
so
of meat.
type of meat, right? The quality of the meat, the age of the meat. You don't want to start with a 7-day-old meat here and then like a fresh cut of meat, right? So you need to be consistent in that regard. Anything else? Temperature, yeah, good. So the environment,
Yeah, same environment.
maybe two more things.
The time in which you put the meat in the containers have to be the same.
That's right. Duration. Are you gonna leave them all outside for 5 days? By ingredient, MD, do you mean like the kind of meat, right? Like the type of meat?
Only meat or along with the meats, some something that can protect the spoil.
Oh, like you mean like putting some stuff on the meat? Like,
Yeah.
okay, so like, he probably didn't do that, but like if you were to do it, then you have to make sure that they're all treated the same way, right? Okay.
Yeah.
Okay, so I think we got some good thing. Anything else you guys want to add, or are we good?
I have a question.
Yeah, Natalie, go ahead, please.
Does the material of the container matter?
Sure. Okay, so the same material for the jar. Okay, that's good.
Can we say time, the test time? I mean, maybe
Yeah,
like 3 days,
exactly.
4 days? Yeah,
Yeah, the duration, right? Okay,
duration.
number of days, right? Very good. All right, so that's what happens, and surely enough, that's what he did. And he left these things outside or on the counter. I don't really know. Uh, there are different accounts of what actually happened, and then he checked it after a couple of days. So what do you expect to happen? Well, common sense will tell you this thing is going to be buzzing around with flies. Okay, flies all over, and then maggots is going to be crawling all over the place. Okay. If you are not convinced this will happen, try it this summer. Okay. You will never forget the results. How about this one? If you have a jar with a net on top, flies or no flies? What do you think?
Flies.
Flies, yeah.
But little.
That is right. Okay, that you will have flies, but the flies will just be buzzing around the containers. It's not going to be on the meat. Probably going to have some maggots crawling around too. If the net is fine enough, the maggots is not going to fall through. So the meat is, it might look rotten, but the flies are concentrated on top. And over here, no flies, no maggots, because it's completely sealed. Okay, the meat might still be gross on the inside, but there will be no flies. All right. So that's what you would expect, right, from something like this, based on our common sense. But again, in the past, people not necessarily know these things for certain, right? So his conclusion was that spontaneous generation is not true because if it was true, then you would see flies in all three of the groups, right? Not everybody was convinced with Rady's experiment. Oh, by the way, I have to skip the break today, okay? Because we still have a lot of slides to go through. So I'm sorry. If you need to go for a break, help yourself. Just watch the recordings after. All right. Anyway, so he did the experiment and concluded the spontaneous generation is not true, but not everybody was convinced. All right. Some people argue sure, spontaneous generation might not be true for large things like maggots and flies, but it might still be true for microorganisms, right? For like bacteria and things that we cannot really see with our naked eye. So the question was finally definitively answered by this person. His name was Louis Pasteur. Louis Pasteur. You might not have heard of his name, but you are definitely benefiting from a process that he invented. If you drink milk or if you consume honey, what process am I talking about? You can't drink milk directly from the cow, right? You gotta go through this process first before you can drink them. What process are we talking about? That's right, Melissa, pasteurization, okay? Same thing with the honeys. And I know people consume raw honey, and I know some people consume raw milk as well, but it's not sanitizing, right? It has bacteria in it. So pasteurization kills off all these bacteria. That's credited to this guy. Anyway, besides the pasteurization, Louis Pasteur did another set of experiment that would definitively show that spontaneous generation is not true. Right? So here we go. Let's write down. Let's draw another note for his experiment. This one's going to be short. Okay, so this is Pasteur experiment on spontaneous generation. So for him, he has two flasks. And there's one flask here. And he has another flask that looks the same. And this is the control. And this is the treated group. He's gonna fill it up with some broth. Some broth, like chicken broth, beef broth, doesn't matter. Broth. So both of these are going to be heat treated, as in like you boil it, okay? Heat treated broth. Right? And this treated group, he put a special neck to the flask. Okay? This is called a swan neck top, as opposed to like an open top. Open top. Okay, so what's the purpose of heating up the broth? That actually is part of standardization. By heating the broth, right, this ensures the broth is sterile initially. Okay, heating the broth will kill off all the microorganisms and make sure there's nothing alive in the broth to begin with. And so afterwards, he left the flask out in the open, and he came back to look at it after, I don't know, a few days maybe. And then he examines it. Yeah, examined it and look at it on like day 5 or something. Okay, look at it on day 5. Okay, so on day 5, what does he see? Well, for the control one, for the control group, he noticed microorganisms. Okay, so there are microbes in the broth. Okay, and over here, no microbes in broth. Right? So initially, there was nothing alive there. He killed it all off with the heat. But after 5 days, the control group has microbes, but not the treated group. Right? So what does that tell you? Well, if it's the open top, you and I, we know now that things can just fall into the broth from the air, right? And the microbes can be carried by dust particles and it falls into the broth and then it grows. But if there's the swan neck, right? Sure, things can fall down, but then they are kind of like stuck here. They cannot climb uphill and go to the broth, and so the broth remains sterile. Right? So based on this result, he showed definitively that spontaneous generation is not true. Okay, the broth did not give rise to the microbes. The microbes land into the broth from the air, right? And that is how finally the spontaneous generation theory has been rejected. Does anybody have any question before I move on? Okay, in case you missed it, if you go to Lecture 1 folder, Study Resources, there is a Video Resource tab. Click onto that. Here is the this one you should watch it. Okay, this one is the Rady and Pasteur experiment. Okay, it's basically what I just explained to you. Okay, so take a look at that. It will be helpful, I hope. All right, poll time. Go ahead. Anyone else before I close the poll? We're looking for the independent variable. Okay. Independent variable is the variable that you are in control of in the experiment. So for Louis Pasteur's experiment, he controlled whether to have an open top flask or one with the swan neck top. That is the only thing he changed, and that's why the answer is B. It's B. Okay. Whether the flask was initially boiled or not, that's actually part of standardization. Right? He actually boiled both the contents of both flasks, right? Not just one. Okay, there is another thing going on in the internet. There's a lot of weird stuff on the internet, but one of the debates that are going on the internet is like I saw this a while back. Right? They're saying if you water your plants with microwaved water, in just 9 days, you're gonna kill your plants. And I guess the person is trying to tell us microwave is dangerous. If the microwave water can kill the plant, it will definitely kill us if we use it. I think that was the point. What do you think? Let's do a poll. There's no right or wrong answer. I just want to see what people think. Do you think A, this is true, or B, this is nonsense? Okay. Choose A if you think this is true. Watering your plants with microwave water. Of course not while it's like boiling hot. For God's sake, you're gonna kill your plant for sure. But like after you cool the water back to room temperature and then you water your plants with it, do you think it's gonna kill your plants? A for yes, it will kill your plants. B for no, this is not true. What do you guys think? Very well. Okay. I love it. Okay. It's half and half. Half of you think this is true. Half of you think this is not true. Well, this is something you can do an experiment to find out, right? Okay. I know you're not going to do experiments, so I'm just going to spoil it for you. Okay. This is not true. This is absolutely not true. You can microwave your water. Chemically, the water is the same before and after you microwave it. It just got harder. Okay. As long as you cool it back down and then you use it to water your plant or use it to shower, to drink, to cook, doesn't matter. Okay, it's not going to be poisonous. This is completely not true. Okay, as with many things on the internet, there's a lot of false things. Okay, so there you go. Lastly, we are going to spend some time talking about experiments that involve human testing. right? Everything we learned so far, the only humans involved is the person who's doing the experiment. But of course, there are experiments that needs to be done on humans, especially if we're trying to investigate the effectiveness of a drug, right? The safety of a vaccine, so on and so forth. All those things needs to be done with actual human beings. And when we deal with humans, when we do experiments with humans, there are certain ethical guidelines that needs to be followed. Right? To name a few, you need to have their consent, okay? And it needs to be an ongoing consent. Right? If they want to withdraw halfway, you have to let them. Right? You can't be like, oh, too bad. You said yes at the beginning. We're gonna keep you until the end. Right? That's unethical, right? We cannot do that. It has to be voluntary. You cannot, coerce people into doing it. You cannot force people into doing it. They have to voluntarily want to participate in the study. And you have to do reasonable, there has to be reasonable safeguard in place to protect them from both physical and mental harm. All right, so these are some examples of things you need to consider when you do experiments that involves human. There is like a whole ethic boards that needs to approve experiments involving humans. When we deal with humans, there is also the placebo effects that we need to take into consideration. Okay, so what is a placebo? A placebo is a sham treatment. It's not real, right? It's just a pretend treatment, if you would. And a placebo is useful to minimize bias in your experiment. So I'll give you an example, right? My kids, when my younger one was younger, she would be very dramatic anytime she falls down on the playground or something. Okay, so she fell down and there's not even bleeding or anything like that. She just falls down a little tiny scratch, a bit of skin is peeling off it. She would be so dramatic, have a full-fledged meltdown. Okay. And then I would take out a Band-Aid and then I would put the Band-Aid on and then she would stop crying and be all right. Did the Band-Aid do anything? Absolutely not. Did she need a Band-Aid? Nope. But the fact of having a Band-Aid on makes her feel better. Right? It's a psychological comfort, if you would. Okay? And that's what a placebo effect is. Right? A lot of times, it's not like the thing is doing anything for you physically, right? But it's just like, psychologically, you feel better. And we want to minimize these psychological effects when we're testing drugs. We don't want people to feel better because they believe the drug to be working when in fact it's not doing anything, right? So by including a placebo, we minimize these kind of bias and misinterpretation of the results. Right? Any question about placebo? Okay, so setting up experiment. I think we've wrote enough notes for that already. Basically, for humans, instead of having the control group and the treated group, we now call the control group the placebo group. That's the only difference. Okay, the placebo group, the group that's going to be receiving a fake treatment. They don't know they're receiving a fake treatment. We don't tell them. That defeats the whole purpose of having a placebo. But we're gonna give them something that is a sham treatment. It's not the real thing. Okay, I'll give you an example of that in a bit. But first, I want to show you this example of placebo being used in other settings. Okay, so this is not related to doing an experiment at all. This is a use of placebo in birth control pills. Right? So there is a birth control pill called Freya 28, and it comes in a package like that. There are 3 weeks of the pills, the actual medication, okay, for the contraception, and then there is a week of placebo, the green pills. And these green pills does absolutely nothing. They do not provide contraception for the person taking it, but it is included in the package. Can someone tell me why Why are they including a week of placebo? I am paying the full price for the drug. Why am I getting a week of nothing? What's the purpose? Anybody? For profit? They
For
just want to scam you.
remembering.
What's that? I'm sorry.
For remembering.
That's right. Okay, thank you very much, Charmy. Yeah, that's for keeping track of time, okay? So people who are on contraceptive, they will take the pills and then they will stop the ovulation basically. But it will also stop the period, right? Okay, and it's not good to not have the menses because if the hormone is too high for too long of a period of time, it could lead to other health problems, right? So like after taking 3 weeks of the contraceptive, it's recommended to go on the placebo, the fake pill, and basically stop the hormone treatment, and then you allow the body to have the to end the cycle, right? And then what happens is when some people when they're off the pill, it's easy to forget what day it is. Okay, like oh, when is it the fourth day that I missed the pill? When am I supposed to be going back on the white pills? Like, is it today? Is it tomorrow? Or do I wait a few more days, right? Like it's hard to keep track of time. So basically, that's what these placebo pills are. They help you keep track of time. Okay, like you take it, and then when you run out of green pills, you're like, oh, I know it's time to start the next pack, right? That's what the placebo is for, right? Okay, so why am I talking about this story? Well, the company that makes this drug, they messed up. Okay, they made a mistake. There was a lot of the pills, a lot, okay, LOT, like a batch, okay, a batch of the pills, where they mixed up the placebo and the contraception. All right, so you get 3 weeks of the green pills and 1 week of the white pills. All right. And people who are not familiar with the product, if they're using it for the first time, for example, they might not be familiar with the color coding. So they will be taking 3 weeks of nothing and then 1 week of the drug, right? And that's really bad if your goal is to prevent a pregnancy, because you're taking the pills, you think you are going to be, not getting pregnant, but in fact, the pills are not doing anything for you. Okay, so they found out that, and then they had to issue an emergency recall. And they're saying people who have the lot number that has the mistake, you have to go on to backup contraception, right? You are at risk of getting pregnant if that's something that you are trying to avoid. And so there you go. The importance of having the right placebo in the right place for contraception.
Because who doesn't know that will take the green pills first, maybe.
Oh, you mean for the one that was swapped?
Yeah, that one, the
Yeah,
green.
so they wouldn't know exactly, right? So they would be taking the green pills, 3 weeks of green pills, and then they would take 1 week of the actual contraception. But
Mhm,
the green pills, like I said, would be ineffective, right?
mhm.
All right, back to our regularly scheduled program. When we do an experiment, it's important to consider, um, how to do it in a way that ensures the accuracy of the result. Right? So one way to kind of boost your confidence in the result is to do what's called a blind experiment. In a blind experiment, the subjects, as in the people who are participating in the testing, they don't know what kind of treatment they are receiving. Okay, we don't tell them. Right? Okay, we might be giving them the placebo, but we don't tell them. Okay, once you tell them it's a placebo, then it defeats the purpose of having a placebo, right? Remember, the placebo is to minimize psychological effects. Okay, but sometimes, so that's called a blind experiment. Okay, the person receiving the shots in this case, they don't know, they're blindfolded. But the people who are doing the experiment, they know. But the gold standard for doing experiment is a double-blind experiment. In the double-blind experiment, both the person receiving the shots, they don't know, and the person who's giving it also not know. So they are both blinded. Okay? Some other third party who's not financially invested in the experiment, they would know. They would have the key to decode the data, and that's important, especially when we test drugs that potentially could be worth millions and millions of dollars. There is a invested financial interest in the pharmaceutical company for the thing to work, right? So we don't want them to be biased when it comes to interpreting the results, right? So we need it to be done in a double-blind setting, right? And it's some other third party that will be able to interpret the results without bias. All right. So let's take a look at here. We have a new drug. I made this up. It's called Sleep, and it is a drug that is supposed to reduce the symptoms of jet lag. All right? So for those of you who don't know, jet lag is when you go to a different time zone, your body's all messed up, right? Like it's day becomes night and night becomes day, and then your sleep cycle is disrupted. You might get headaches and whatnot. So like there's a lot of symptoms, can't sleep, associated with jet lag. All right. So there's a pill that is called Sleep, and we want to see whether or not it reduces the symptoms of jet lag. So here we go. We have the control group here, which is also called a placebo. These are the people where I give them a sugar pill, okay, a candy, so to speak. They don't know it's a candy. All right, we give them the pill and we're like, this is going to help reduce the symptoms of the jet lag. Okay, you go take it. And then we're going to have the treatment group, another group of people, and we're going to give them the actual drug that we're trying to test, right, the sleep pill. And then afterwards, we're going to evaluate their symptoms. So here are the results. For the placebo, for the control group, close to 80% of the people report they have symptoms of jet lag. And then for people who are actually taking the experimental drug, only 30% of them report jet lag symptoms. So do you think the drug works, or do you think it does not work? So let me do the poll for you. Go ahead. If you think it works, A. If you think it does not work, B. If you're not sure, choose C. Okay. Just waiting for more results to come in, and then I'll explain this to you. All right. I have half and half results, half the class thing. This is effective. Another half thing is not effective. And then there's a comment. Kansa said, isn't that like deceiving though, since it's not treating but only make them feel better about it? Yeah, but that's the whole point, right? That's the whole point of including a placebo. Right? You want to see if this is a psychological effect or not. Okay, let me explain. So the correct answer, by the way, if this is the result, I would say that the drug is actually effective. The drug is effective, and
A.
here's why. Sorry, go ahead. Did you say something? Oh,
no.
you said A. Okay, yeah.
Yes,
So
yes.
yeah, thank you. So it's effective, right? Why? Well, let's take a look at the control group. This is the placebo. This is sham, right? Sham treatment, fake treatment. Okay, you're just giving them candies without telling them. Is candy going to help you sleep better and not have jet lag? Probably not, right? Okay, so it's not surprising you see a lot of people, almost 80% of people reporting jet lag. Okay, so that's expected when you are not giving them anything. You might wonder, well, I mean, there's still 20% reduction, but you got to understand jet lag does not affect everybody, right? Okay. Some people are more severe than others. There are people who travel a lot and they go from time zone to time zone and they're not affected by jet lag, right? So this 20% is 20% reduction is probably people who wouldn't complain about jet lag to begin with anyways. However, when you give them the drug, you can see there is a 70% reduction in jet lag. Only about 30% of people still have jet lag, right? So I would say, yes, the drug is helping them, right? People who are taking it, less percentage is experiencing jet lag. That's why, based on this result, I would say the drug is effective. Now, I am oversimplifying things. I don't know if I feel like some of you here have done, research in science before. To make this actually, more convincing, you have to consider many things. You have to consider the sample size, right? How many people are we having in each group, right? Is it just 5 people versus 5 people? If it is, then it's not really convincing results, right? Even if it's like 50 people versus 50 people, it might not be convincing, right? The bigger the sample size, the more confidence you have in your results. Okay? And of course, you have to do statistical analysis. You have to calculate, there are some formulas that you can use to calculate, whether or not you have confidence to making a conclusion or not, right? But putting all those things aside, all right, just looking at this at face value, I would say the drug is effective. Okay. Does that make sense? Those of you who chose B, those of you who thought it was ineffective, have I convinced you otherwise? If not, please ask me a question. I would clarify it for you.
Please, again, make it clarify.
Sorry, did you say you want me to clarify it?
Yes, please.
Okay. Do you have a specific question though? That specific thing you want me to clarify, or just explain the whole thing again?
Just overall.
Overall? Okay, sure.
Yeah.
Look, let's recap what a placebo is. A placebo is not supposed to do anything. Okay, that's the key thing to remember. A placebo is fake. Okay, it's a sugar pill, right? I keep on saying. Right. So when you give the placebo to the people, you are not expecting them to get better. Right? You're not expecting them to have less jet lag symptoms, which is what we see here. Okay, which is what we see here. We see a lot of people, 80% still have jet lag. Okay. But when you give them the drug, less people have jet lag. That's why we can say the drug is helping with the jet lag. If the drug is not doing its job, you would see as high or even higher number of people with jet lags, right? That there would be ineffective. Okay, but the fact that it got less jet lag symptoms, that means it's effective. Now, what about this? Do you think this is effective or ineffective? Let's try this one more time. Okay. If you give them the sugar pill and you give them the actual pill, both group experience less symptoms of jet lag. Do you think this is A, effective, or B, ineffective? I'm talking about the drug.
Did you say A effective?
Yeah,
B
A is
ineffective?
effective. Yeah. Oops, sorry. A, effective. B, ineffective. Okay,
So
and if you
what are we talking about? I didn't understand. What is the question
the
here?
question is, if you look at the result here, do you
Okay.
think this drug is effective in reducing jet lag symptoms? Do you think the
Oh,
drug works? Right?
all right.
So is it A, it works, or B, it does not work? That's the question. Okay, anyone else before I close the poll? All right. I don't think I'm doing a good job because we are still half, just like before. We still not half the class still think, it works. The other class, half of the class think it doesn't work. Let me try again. Okay, let me try again. Okay, the correct answer for this particular result is that it is ineffective. Ineffective. The drug is not working. The drug is not working. How do you know? Okay, listen. It's not so much, thank you for pointing that out, Alexander. It's not so much that this is like higher than that. That's not the key thing here. The key thing that tells me this is not working, that tells me the drug is not working, is that the placebo works as well as the drug. Listen, if I give you a piece of candy versus a drug, okay, and they both will help you sleep better, are you going to choose the candy or are you going to choose the drug? Right? I think the answer is the candy, right? Like, why would you take a drug when the candy is as effective? Okay? And that's what the result is showing here, right? Just the sham treatment, if you give them just a fake thing, they are able to have less jet lag symptoms, right? Compared to the actual drug. This suggests to you jet lag might be more of a psychological effect. So you remember, these people don't know they're taking the placebo. You give them a pill, you're like, oh, this is gonna help you. And then if they believe that and they end up sleeping better, right, less jet lag symptoms, then it tells you it's just a psychological effect. It's all in your mind. It's not actually the drug that's doing the treatment, right? So over here, right, the actual drug performs just the same as the placebo. Therefore, it is ineffective. Compared to before here, the placebo did not really do too good. It's not really helping you, but the pill is helping you in reducing jet lag. Therefore, it's more effective. Are we together? Maybe ask me something, guys, please. Anything.
Yeah, so gap should be like a bigger if you want to see the effective of medicine drug.
Yeah, I mean, but it's not necessarily just the gap itself, but the fact that the control group has no effect in this case, but then it has an effect in this case. That's how you determine whether it works or not, right? But you're right. Looking at the difference between the height of the bars could help you decide whether it's effective or not as well. Okay, we're going to do another question here. Hopefully it will be a little bit better. Please go ahead and do that. Okay, let me take this up with you. 1 milliliter of experimental drug diluted in saline solution. Saline is just salt. is injected into 20 pregnant mice to determine possible side effects. Which of the following is a suitable control for this experiment? So if we are testing the drug on pregnant mice, anything that has male in it is not going to be the answer. Anything that's non-pregnant will also be wrong. And so is it 20 pregnant mice injected with 2 milliliters of drug? Do we give them more drugs in the control, or do we give them just saline? Well, remember, the control is the group that is not receiving modifications, and so you're just going to be giving them the saline. In other words, no drug, right? And then you'll be able to compare the results with the control. So some of these questions are gonna show up on the quiz. Make sure you go through them yourself and have a good understanding of it. I know we are almost out of time, but we only have 1, 2, 3, 4, 5 slides to go through. If you do have to go, doesn't matter. Watch the recordings after. I'm just gonna finish the last few slides. So finally, we should understand correlation versus oh no, I don't know what's happening to the slides. They are not showing up. Give me a second. Let me try to relaunch that. Sometimes you talk too much and then the slides start to not work. It's coming. Give me a second. All right. So we should understand the difference between correlation and causality. Correlation means a relationship between two variables. Just because there is a relationship between two things does not necessarily mean one thing causes the other. Right? For example, if a person is stressed out here, then it looks like they are more susceptible in getting a cold. Right? So there's a correlation. But does that mean stress caused the cold? Not necessarily. There could be other underlying situations that cause the person to be stressed out. Maybe they have other illnesses. Maybe they're not eating well. Maybe they don't exercise enough or a little sleep. All these things could also result in a higher frequency of cold, right? So just because we see a person is stressed out and then they're more likely to get a cold, we cannot make a direct link between these two things. Right? There are often underlying situations, underlying things that could be contributing to both of these things. So the key takeaway here is that correlation does not necessarily imply causality. There is a website you can visit yourself if you want. It's called Spurious Correlation. It shows random things that have very high correlation with one another, but they absolutely do not cause each other to occur. For example, you can see the red graph here shows the amount of cheese consumption per capita, and then the black graph here shows the number of people who die by becoming tangled in their bed sheets. Okay, apparently that happens. And you can see a very close correlation. But does eating more cheese makes you more likely to become tangled in your bed sheets and die from it? Absolutely not, right? I would say. All right, so this is a perfect example of two things with close correlation, yet one has nothing to do with the other. Right? There are more if you're interested. So if you do a quick search online, or even if you scroll through your news feeds, look at Facebook and Instagram and whatnot, there are often a lot of these headline clickbaits, if you would, okay? And a lot of times they have conflicting information, right? So Some of you probably drink coffee, right? Others not. And there has been this ongoing back and forth about whether drinking coffee is good for you or not. So I did a quick search between February of 2016 and April. I probably can update this slide, but in that short 2 months, I was able to found conflicting things. For example, drinking more coffee might reverse liver damage from booze. That's a pretty good thing. That if you're a coffee drinker, you will look at that and you're like, yeah, drinking coffee is good. I should continue my habit. And then here, coffee. This is another news. I wouldn't call it news. This is another article. Okay, another article. Coffee consumption in either parents may raise miscarriage risks. Okay, and if you're someone who does not drink coffee and you look at that, you're like, yeah, I knew drinking coffee was bad, right? So we have these things called confirmational biases. If you look at articles that reaffirms what you believe in, you are more likely to accept those articles. Okay, and then you forward it to your friends and whatnot, and then it just kind of spreads, right? But my point is, a lot of these things, you should look at the original study and make a decision on whether or not it's trustworthy science. So, for example, who funded this study, right? How many subjects were involved in the experiment? Did they include a placebo? Did they have the proper control and the treatment groups? Right? Like how is the science being done? Right? Does it follow the scientific method, for example? Right? And a lot of times, if you look closer into these articles, a lot of them is just not really good science, if at all. Okay, a lot of them is just based on anecdotal evidence, and there are a lot of influencers online that try to skew you one way or the other, right? And they don't necessarily have good science to back them up. And so how do you decide whether it's good science or not? Well, generally, there are two sources here. We have what's called primary sources and secondary sources. A primary source is original documentations or the original research. Right? This is the actual studies written by the person who performed the experiments. Right? So generally speaking, they are more trustworthy. There are situations where they're not, but generally they're better, okay? Because they are printed in peer-reviewed journals. What that means is when they publish their work, there are other experts in the field that will basically criticize your work. They scrutinize it and they make sure it's being done to a good standard, scientific standard, before you're allowed to publish it. Right? So generally, they are more accurate. It includes other things like interviews, reporting from a live scene. It's a first-person original work, if you would. That's what the primary sources are. Secondary sources are what most of the stuff online are. Okay, they are encyclopedias, which is like collection of information. I'm not saying they're not accurate, okay, but you gotta be careful when you use some of these things, especially if it's from like magazines or like from a blog, just like random articles that you found online, or even if it's from newspapers, right? It's not without bias. As you might know, there are news outlets that are tilting, politically one way or the other, and how they report it might be a little bit biased, right, in that regard. So be aware of the different kind of sources there are. And in learning about the scientific process, you can use the things we've learned to evaluate whether the things you're reading are good science or not. Okay, so that is it for the first lecture. Thank you for your time sticking around. On Wednesday, we will begin with lecture 2. If you missed the first class, you can watch the recordings. If you're not sure where to find things, you can always email me. My email is on the first page of every PowerPoint slides. Okay, I'm just gonna show you here, right there. vwong@centennialcollege.ca. Right, just let me know what you need help with. I'll be happy to show you. All right. Thank you. Have a good day. I'll see you all on Wednesday.
Thank you so much.
See you.
Bye.
Bye bye.
Have a good day. Bye.
Goodbye.
Bye. Have a good one.